Assalamu alaikum everyone. Today we will start Numerical 2.7 Kinematics unit number 2, 9th class. Now let's see what is the statement of this problem. A train starting from the rest accelerate uniformly and attain a velocity 48 km per hour in 2 minutes. It travels at this speed for 5 minutes. Finally, it moves with uniform retardation and is stopped after 3 minutes. Find the total distance traveled by the train. First we have to enlist what is given in this numerical. As we know, a train moves from the rest. So as the train was moving from the rest position, so it has initial velocity Vi is equals to 0 meter per second, and accelerate uniformly and attain a velocity of 48 kilometers. Its final velocity that train attains after the 2 minutes is 48 kilometers per hour, and train took 2 minutes to achieve this velocity from the rest position, and it further travels. This is substituted as t1. Then train travels at the 48 kilometer at this uniform speed for the next 5 minutes, and finally the brakes were applied and the train was stopped within the 3 minutes. So a third time is here, t3. This is 3 minutes. What we have to find, we want to find the distance s traveled by the train in all these 3 time interval. So because in all these 3 time interval the acceleration is different and the conditions are different with respect to accelerations only, so there are 3 distances. So s1 for time t1, s2 for time t2, and s3 for the time t3. We have to find all these 3 distances, and then we have to add up all these distances to collect our total distance. Now let's quickly understand this problem with the help of velocity time graph. So velocity on the y-axis and time on the x-axis. The train starts from the rest. Initially at the 0 time the train has 0 velocity, and it gains its velocity as it moves. So this is initial velocity, that is 0, and it attains some velocity Vf 48 kilometers per hour. The train took the time to achieve this velocity is 2 minutes. Then train maintain its velocity of 48 km per hour and travel on this velocity for some time. This time is the 5 minutes. Then train stops with the uniform retardation, and finally it stops. Its velocity becomes 0, and it took further 3 minutes in doing this. So we have to solve our problem in the 3 parts. These are our 3 zones of problem solving: 1, 2, and 3. In the first part you can see the velocity is changing from initial to the final, and we have the time. So to calculate the distance we can use 2 equations of motion. The first is the second equation of motion, s is equals to vit plus half at square, or we can use the third equation of motion, 2as is equals to vf square minus vi square. In calculating the distance from these 2 equations, the one parameter that's still unknown to us in this problem is acceleration. So first we have to calculate the acceleration. To calculate the acceleration we use the first equation of motion. Vf is equals to initial velocity plus a into t, because in the first part we have Vf, Vi and the time t1. So we can calculate the acceleration for our first part of the numerical. Now putting the values. So before putting the value, here is the unit of velocity is 48 kilometers per hour. This is not the SI units. To convert this kilometers per hour into meter per second, multiply this with 1000 and divide by 3600. 13.33 meters per second. Now we know the time also in the minute. It is also not the SI units. To convert the minutes into the second, which is the SI units, multiply this with 60, multiply this time with 60 also, and this with also. T1 comes to 120 seconds, T2 is equals to 300 seconds, and T3 is equals to 180 seconds. Now putting the values, 13.33 meters per second is equals to, the initial velocity is 0 plus a into the time is 120 seconds. 13.3 meter per second divided by 120 second is equals to 8. 0.11 meter per second square is the acceleration of the train when it achieves a velocity of 48 kilometers in 2 minutes. Now we can use these two equations to find the distance. So select any of the equation and you can calculate the distance. I will select third equation of motion. 2as is equals to vf square minus vi square. 2 into 0.11 meters per second square. S is equals to 13.33 meter per second whole square minus 0 meter per second square. 0.22 meter per second square, 176.89 meter square per second square, and this is the 0. Now S is equal to 176.89 meter square per second square divided by 0.22 meters per second square. S1 is equals to 804 meters. Now to calculate the distance traveled by the train in the part number 2, we can see that the train was moving with the uniform velocity. When the train was moving with uniform velocity, it has zero acceleration. Its initial velocity is equals to its final velocity. So in that case, we can use second equation of motion. If we use the second equation of motion, S to calculate the S2, VIT plus half AT square. Because train was moving with uniform velocity, so its acceleration is 0. So this whole term is converted to 0. Only the formula left behind is S2 is equals to VI, or simply you can say VT. S2 is equals to, the velocity of the train is 13.33 meter per second. The T2, the time for which the train moved with this velocity, is 300 seconds. So distance calculated when train was moving with uniform velocity is 3,999 meters. Now to calculate the distance when the brake was applied and velocity is changing from 48 kilometers per hour to 0 meter per second, in the third part, we first have to calculate the retardation. Retardation is deceleration. It is the acceleration, a negative acceleration, because in that case the acceleration vector is in the opposite direction to the velocity vector. That's why acceleration value is taken as negative, and it's also called retardation. So to calculate the retardation or simply acceleration, we use first equation of motion. So now Vf is equals to Vi plus At. As we know, the train's final velocity. So in that case, the final velocity is the 0, because train was already at 48 kilometers per hour, and when it applies the brake, its velocity decreases to 0 meter per second. So this is the final velocity, and it is the initial velocity. So 0 is equals to, because we have converted 48 kilometer into meter per second, it's equal to 13.33 meter per second plus A, and train took 180 seconds, T3. 13.33 meter per second divided by 180 seconds, negative 0.074 meter per second square. This is the retardation for the train. We have to calculate distance as 3 with the help of third equation of motion. 2as is equals to Vf square minus Vi square, because we have acceleration value or retardation value here. So 2 into negative 0.074 meter per second square, because this distance is s3. S3 is equals to the final velocity, that is 0 meter per second square. The initial velocity is now 13.33 meters per second square, negative 0.148 meter per second square. S3 is equals to negative 177.68 meter square per second square. S3 is equals to negative 177.68 meters square per second square divided by negative 0.148 meters per second square. meter approximately. Now to calculate the total distance, S is equals to S1 plus S2 plus S3. So S1 is 804, S2 is 3999 plus 1200. Journey is S is equals to 6003 meter, approximately 6000 meter. So that's all about numerical 2.7. If you understand this problem, like my video and share my video with your friends and subscribe my channel. Thank you very much.